A reboiler is basically a heat exchanger that heats bottoms liquid from a distillation tower and vaporizes the lighter components in it. Often, a reboiler provides most of the heat that's needed for distillation to occur in a tower. Two ways that reboilers can be categorized are by how fluids circulate between the tower and the reboiler, and by the location of the reboiler in relation to the tower. Fluid circulation between the tower and the reboiler can be forced circulation or natural circulation, and a reboiler can be an external reboiler or an internal reboiler. Let's begin with a look at forced circulation systems. In a forced circulation system, a pump moves fluid between the tower and the reboiler. Furnaces like this one are sometimes used as reboilers in forced circulation systems. This type of furnace is known as a fired reboiler. We can use an illustration to see how this system operates. It includes the bottom of a distillation tower, a fired reboiler, and a pump. During operation, part of the liquid from the bottom of the tower is pumped to the reboiler, where it is heated by the burning of fuel in the furnace and its lighter components vaporize. A mixture of the vapors and any remaining liquid is returned to the tower, where it provides heat for the distillation process. The pump also moves part of the liquid from the bottom of the tower to storage or to other processing equipment. This liquid is the tower's bottoms product. A shell and tube heat exchanger can also be used as a reboiler in a forced circulation system. Steam is often used as the heating medium in this type of reboiler. As the steam gives up its heat to the liquid in the reboiler, the steam turns to condensate, which flows out of the reboiler. The vapor-liquid mixture that is produced in the reboiler is returned to the tower. Shell and tube reboilers use various fluids as heating media. For example, instead of steam, some systems use a hot fluid from another process, such as the hot product from a process reactor. As we've seen, a forced circulation reboiler system requires a pump to move liquid. Reboiler systems that do not use pumps to move liquid from the tower are called natural circulation systems. In these systems, liquid circulates naturally as a result of the difference in density between the liquid in the tower and the liquid in the reboiler. One type of reboiler that's used in natural circulation systems is a Thermo Siphon. A Thermo Siphon is basically a shell and tube heat exchanger. We can use a simplified illustration of a Thermo Siphon and the bottom of a distillation tower to see how liquid is circulated without a pump. Some of the liquid in the bottom of the tower is taken off as bottoms product. The rest of the liquid flows by gravity into the bottom of the Thermo Siphon. As steam is fed into the Thermo Siphon, part of the liquid in the Thermo Siphon vaporizes. The mixture of vapors and hot liquid is less dense than the liquid at the bottom of the Thermo Siphon. The lighter, less dense mixture of vapors and hot liquid rises in the Thermo Siphon and is returned to the tower. When the mixture of hot liquid and vapors leaves the Thermo Siphon, cooler, denser liquid from the tower flows into the Thermo Siphon, establishing flow through the reboiler system. Another type of reboiler that's commonly used in a natural circulation system is a kettle reboiler. A kettle reboiler looks a lot like a shell and tube reboiler. The major difference is a dome-shaped section on top of the reboiler. A hot fluid, such as steam, is fed into the tubes of the kettle reboiler. Part of the liquid from the bottom of the distillation tower flows into the shell. A weir ensures that the tubes in the reboiler are kept covered with liquid. The vapors collect in the domed space in the shell and are then returned to the tower. Any liquid that is not vaporized is bottoms product that is sent on for further processing or storage. Another way that reboilers can be identified is by their location in relation to a distillation tower. A reboiler that is located outside of a tower is an external reboiler. All of the reboilers we've seen up to this point are external reboilers. A reboiler that is mounted directly into the bottom of a distillation tower is an internal reboiler. This particular internal reboiler is often called a heating element or stab-in reboiler. In general, internal and external reboilers work in much the same way. Steam or another hot fluid is used as the heating medium, and the vapors or vapor-liquid mixture that is produced is used in the tower to provide heat for distillation. An important part of a distillation process is the overhead system, and one important piece of equipment in the overhead system is a condenser. A condenser in an overhead system is often referred to as an overhead condenser. The condenser is used to convert the vapors produced during distillation into a liquid. It does this by lowering the temperature of the vapors. One way that a condenser in an overhead system can be classified is by the type of cooling medium it uses to cool vapors from distillation towers. Among the media most commonly used are air, water, and refrigerant. One type of condenser that uses air to cool vapors is a fin fan or forced air condenser. During operation, motor-driven fans blow air around tubes in the condenser. Vapors from the tower flow through the tubes. The air absorbs heat from the vapors, causing them to condense into a liquid. The liquid or distillate then collects in a receiver. Water can also be used as a cooling medium. The water in a water-cooled condenser has the same basic function as the air in a fin fan condenser. This is a simplified illustration of a condenser that uses cooling water to convert vapors into liquid. The condenser consists of a shell, tubes, tube sheets which support the tubes, a vapor inlet, a cooling water inlet and water box, a cooling water outlet and water box, and a distillate outlet. The illustration also shows a receiver. During normal operation, cooling water enters the cooling water inlet, fills the water box, and flows through the tubes. The cooling water then passes through the outlet water box and leaves through the cooling water outlet. At the same time, the product vapors enter the condenser through this vapor inlet and flow around the tubes. When the vapors come into contact with the surfaces of the tubes, heat is transferred from the vapors to the cooling water in the tubes. As a result, the cooling water is heated and the vapors are cooled. This causes the vapors to condense on the tube surfaces. The distillate drips off the tubes and flows through the distillate outlet to the receiver where it collects. Refrigerant can also be used as a cooling medium. Like air and water, refrigerant absorbs heat from the hot vapors. A condenser can also be classified by the role it plays in a distillation system. For example, a condenser that condenses all of the vapors from a distillation tower may be called a total condenser. A condenser that condenses most but not all of the vapors from a tower can be called a partial condenser. In this topic, we looked at some of the reboilers and condensers used in distillation systems. Now try some practice questions that relate to this material. In a forced circulation system, a pump moves fluid between the tower and the reboiler. One way that a condenser in an overhead system can be classified is by the type of cooling medium it uses to cool vapors from distillation towers. Among the media most commonly used are air, water, and refrigerant.